Morning. Good morning.
Right. Oh, they can hear us.
Yeah,
That's
yeah.
awesome.
No, it works.
Was there something about not bringing any opinions?
I don't know. I mean,
We're too late for us to change the keynote. There's plenty of opinions.
yeah. This is one of them. If you, without data, you're just another person with opinion, whether you want it or not. So this morning we're going to speak with you about data-driven DevOps. That's obviously a hashtag that we, official one, we invented. No one uses, but you
Us,
will.
and hopefully
Yeah.
you.
And speaking about this kind of stuff and data and opinions, we prepared a special page for you. It's called Show Notes. You go to jfrog.com/show notes, and the slides are already there. The video will be there by tomorrow. Everything that we are going to talk about is there as links, so you don't really need to take notes or take pictures of the slides except of this one.
No, they should take pictures of the slides and tweet them.
Yeah, only for that purpose, because otherwise everything is there. There is a place for expressing your opinions, the ratings, and we leave for feedback and ratings, obviously, and something to say thank you for being here so early today, a small raffle as a token of appreciation. JFrog.com/show notes. The link is also on each and every slide, so even that you don't need to take picture of.
All right, well, this is Baruch Sadogursky.
Baruch on Twitter. I am a developer advocate and head of developer relations at JFrog, and we are obviously great fans and sponsors of DevOpsCon. We have our booth out there to talk about stuff which is related to JFrog, as opposite to this. We won't talk about JFrog products here, but you can definitely go to our booth. We also have super awesome t-shirts. You should visit us. This is Leonid Igolnik.
I am at Igolnik on Twitter. I run engineering at the company called SignalFx, where we build observability tools. God, this is early in the morning.
Too early.
I know, for the third generations of architecture. So if you want to talk about observability, we don't have a booth here, but I'll be around for an hour, so if you want to chat about that.
Yeah.
Let us begin.
Let us begin. So we will start with a very sad story. And that's a story about cobbler children who have no shoes. Poll time, we saw your reaction for beers and everything. We need
we need some more participation.
Yeah, we need to do better
by the raise of hand, how many of you are software engineers in the room?
Almost
about 80%. Yeah, 80%. Keep your hands up. Keep your hands up. Keep your hands up.
How many of you are optimists? Any
Continue
optimists?
to keep your hands up if you're an optimist.
Okay, here you go. Same people, not surprisingly. How many of you think they know what they're doing? Most of the time, at least.
Okay, so we kind of dropped a bit.
It's not.
It's about 70%.
Yeah, but it's the same people. It's the same people, and that makes perfect sense.
There's science for that.
Yeah. So the problem with your optimism is that it is an illusion. You think that you will manage and everything will be good because you think too good of yourself.
You're a professional, of course, with many years of experience.
And that brings another problem. Your self-esteem or your self-confidence is a problem of its own, because once you succeed in something, you are sure that the next thing you do will be as successful as the first one. And
that has only one consequence.
There are a number of consequences. First of all is that's a Venn diagram, and that's officially my favorite slide.
It is a real Venn diagram.
Anyone feels that way?
They're self-confident. They're naturally self-confident.
And optimists, yeah.
But then there's the other thing, right? 80% of the software is 80% done 80% of the time.
How about that?
Familiar with that? Anybody?
Okay, this is...
Baruch and I occasionally indulge in some furniture building, and I remember his wife over the weekend asking us, hey guys, are you going to be done? We were done in 2 hours for most of the 3 days we were building that thing.
Yeah. It was always like 2 hours.
2 hours. In 2 hours we're ready.
Yeah. After some time, my wife, she wanted to prepare food for the time we are done, and then keep it warm, and then just keep it from spoiling, and then she gave up.
Well, I think she went to bed.
Yeah.
And those things are hard to give up, right? That self-confidence, because you've succeeded before and you're doing something new that seems similar to what you've done, hard to give up.
It's also a matter of sunk costs. When you start doing something and you are 80% done, why would you give it up?
It's almost there.
It's almost there.
It's almost there.
Right.
And that's what brings us to this. Who can tell us, what does this picture look like? What's that? What's happening in that picture? Yes, just shout it out. Stand up.
Stand-up meeting.
That's right.
Let's talk about
what happens in engineering and stand-ups, right? Like, we have a bunch of the departments of the typical company, and they all have tools to measure themselves. So sales measures using Salesforce. Marketing probably has something like Marketo or something similar. In support, you have some kind of support system. In financials, they use something for finance. In HR, they have Workday. In engineering, well, in engineering, we have that.
Now, the problem is that when you have systems that omit data, you can talk about that.
You can hold each other accountable.
So sales shout at marketing, you don't give us enough leads, and marketing shouts on HR, we cannot hire any people, more
budget
people.
from finance, right? All of those departments use their systems and use their data to hold each other accountable. So and engineering?
They have discussions, very healthy discussions.
Mostly healthy discussions. And then, of course, engineering is somewhere on the side. Yeah, you can applaud. That's okay. We will love that slide.
Yeah. So we need to fix it, and yeah, let's do that.
Yes.
All right.
So what should we do? We should rewind the video because there's no sound.
And why there is no sound? Is it our fault?
I don't know. It's
take emotion
here we go.
out of
Okay, let's try again. 80% done.
Well, what if we take emotion out of the process and base it on empirical metrics? Then we aren't really making the decision. The data is.
So we can hurt our friends' feelings without taking any responsibility? Me likey.
So I hope you like it as well.
So do we.
And let's talk how we take the emotions out of the discussion and based on data.
Now, data is not new in engineering, right?
We had those metrics even before DevOps. We had separate metrics for each and every silo. There was metrics, good metrics, or metrics in dev. There are some in ops. There are some in QA.
So the question becomes, what happens when DevOps comes and you combine all those three disciplines, and what should you be measuring?
And we're looking for kind of one metric that will take our kind of demolition of silos and everything is bringing together, and we're going to look for this golden metric.
Like we had one in Agile, right? It was called velocity.
Yeah.
So what is that one metric for DevOps? Any suggestions, anybody?
That's too early.
No,
let's just give it. Yeah, no, let's just give them
we
that.
think it's profit.
Yeah.
Right? Why do companies accelerate their development cycles? Why do they adopt those new processes? Typically to make money. Now, the good thing is profit and velocity are very much alike, right? They're easily understandable. Everybody knows what good velocity looks like. Everybody knows what good profit looks like.
They're also very unifying. People can get behind it. When velocity was agile, we need to move faster. Our burn down chart should be better, and everybody get it.
Oh, speaking of burn down charts.
We'll get to it.
We should
and
talk.
Profit is also like, everybody get to it. Speaking about burn down chart, let's do that.
So let's do some baselining. Again, by your raise of hand, who knows what velocity is?
And keep them up, keep them up,
keep them up, keep them up.
Right,
I know it's early in the morning, it's tough. All right. Who knows what a burn down chart is? Oh, some hands went up.
Yeah.
Okay, good. Who has a burn down chart at their job?
Okay, typical. Yeah, now we see
that's getting
most
better.
of the people went down.
Who looks at that every once in a while?
Okay, now we can start counting heads. Hands. We have like
less than a dozen, I see.
Yeah, no,
maybe a bit.
About a dozen.
Most important question: who trusts their own burn down chart?
Okay. Not a single one of you? No, there are a couple of hands.
No,
like
and there are a few over there.
Okay, and the last question.
By the way, nobody from JFrog, interestingly enough.
They're not from engineering, that's okay. The last question for the 4 people
who kept their hands, the most important question: who knows what to do when the burn down chart doesn't look like it's supposed to?
Okay, we have...
I see one person being pointed at over there. That's it.
Yeah, okay. He's probably a speaker about Agile. I would say so.
Yeah.
And those are the only people who know what to do when It doesn't look right.
So what is the problem when you take those three disciplines and mash them into this wonderful color, brown?
Maybe the problem is that you mash them too much and you got the color.
Yeah. The problem with all of those coarsely grained metrics, they're not actionable. Like when the profit is great, everybody's celebrating, everybody's drinking champagne. When velocity is great, we ship a lot of software. But when things are not working as well, how the hell do you change that? What do you do?
So they are two cores, profit, two cores. And I have to say that this definition of DevOps, when we took Dev, QA, and Ops, kind of smashed them together into this weird brown thing, is not a real picture of DevOps.
No. The real picture of DevOps is the canonical Venn diagram, where it's the intersection of those three key disciplines and collaboration between those three types of professionals.
Well, unless you are Netflix, because in companies like Netflix that do mesh everything together,
yeah.
But you are not
Unfortunately,
Netflix.
none of you are probably Netflix.
Yeah, so that's okay. That's okay. What it means is that we have common goals, we have common tools, we have common culture, but specialization still exists.
And it's still important.
Most of the people cannot do everything perfectly. They have their...
I would argue most of the people cannot do everything well.
I would argue most of the people cannot do everything. But that's so we have specialization, right? We have some good things that we do. We know about others. That's the T-shaped personality.
Yeah, you know a bit about a lot and a lot about a bit.
And the most important part that actually DevOps brings is the collaboration between them.
Right.
Same for metrics. Remember the different metrics that we have for each and every department or specialization? We have this common one, but they still exist.
Right.
And the most important part, they collaborate.
That's right. So how do departments collaborate using metrics? We'll give you a couple examples. Here's a diagram across. We have development. What does developer get affected by that ops can deliver, right? For example, build environment times. For example, release pipelines, right? Is this thing stable? Can I push the button and deliver something to production or test environment?
Another example, fake reopen count. If the QA doesn't do their job right and keep reopening tickets which are actually closed, they interrupt the development flow and slow down the velocity and the release cadence.
That's right. And then many others. Like all of those departments can collaborate with each other and can hold each other accountable using those types of metrics.
And obviously, just to remind you, JFrog.com's show notes have the slides, so you don't have to read all of it now.
So let's talk about making software and cooking software with metrics. What do you have to learn about metrics to be successful?
Let's start with metrics categorization. Let's put the metrics into some categories so we will be able to wrap our head about that. The first category is why we even measure.
Like, why do we care? Right. Well, one of the more often known ones is, again, ROI, return on something, right? Return on investment.
Do we do the right thing? Do people line up in front of our restaurant? And that's the first McDonald's in Moscow in 1989.
There's clear ROI in that line.
My sister is somewhere there in this line. And yeah, obviously that's the right restaurant. And the question is why? How do we measure?
Right. Why else do we measure? We typically measure if we wanted to know if we improved on something, right? We track a particular metric because continuous improvement is how you typically go from point A to point B. Those things just don't change overnight.
Yeah, and so, for example, you didn't laugh at our last joke. If we do a better job, you will laugh at our next joke. So we improved. We will try that. The most complicated, but the most interesting one is building trust. If we measure enough and our metrics are good, they build trust. If we promised you something, we delivered it, we measured it. When we will promise you something next time, you will probably believe that we are going to do it.
That's right. So let's talk about how do you measure something, right? How do you get your metrics gathered, analyzed, and processed? You start typically with samples, and there are several types of sample. One of them is complete sample, which I'm sure all of you engaged when you grocery shop. Typically, when you pick fruits, what do we have? Oranges off the shelf. You typically touch every single one of them, and you decide whether you're going to put it on your basket or not. That's your complete sample.
And complete samples are important for the first type of metric, for the ROI, because when you invest money in something, you need to measure everything around it to get the true picture, was it worth it or not.
Now, complete samples require very complex tools. Our favorite, most complex tool you can think about is Microsoft Excel.
Oh, yes.
Right, and here's an example of a complete sample. This is from an actual one of the teams I used to run. We started understanding where we spend our development time by effort over a period of time to make sure that we're investing in things that matter. Something like that requires a complete sample.
And this is a wonderful picture because let me guess that when you did that, this thing, it works weird. This thing, big feature A, I guess that was the highlight of your sprint?
Probably would have been of the release, but it's only 13% of the invested time.
And this is very, very surprising, at least for me, because I expect that when a team works on a feature, it invests 80% into it.
Maybe not 80, but certainly higher than like some of the larger slides here, right?
So
complete samples are important, but they're not always feasible. So the next type of metric is
a representative sample. Sometimes you have too much data. Sometimes you don't need all the data. Sometimes representative sample is enough. This is good for measuring how effective are we, right? If you do something, if you, for example, we'll get to the examples actually. Yep. So samples are good enough for that. You need to make sure that they are representative, right? So you know what? I will give an example. Let's say you measure how long it takes for your team to close a ticket, to close a bug. Right, and it turns out that no one actually feels this how much time they invented in Jira, except of this one guy. And let's say this one guy, they are very, very good. You will have a float picture. Yeah. Let's say they are very, very bad. You will get a float picture. Right. So this representative sample have to be representative.
You have to be careful with that, right? And of course, for those representative samples to be collected over time, your sampling interval is much longer than if you just went and grabbed a complete sample where it's feasible. What else do we measure?
So this is the most complicated one. For accurately predicting the future, you need both. You need as full sample as you can, because that will represent your allocation in the future, or you can trend from it. And it has to be collected over time, because that's the only way you can build a trend.
All right. Well, let's run through some example. Please meet our Scrum Team Avengers. We're going to run through some, hopefully not so anecdotal examples with them and see what they've done by measuring things and how they improved their life.
So you remember how it starts. It all starts with anecdotes from the daily stand-ups. This is how we used to do it, and we used to take what is said there for granted. So one of the examples, Scrum Team Avenger complains that they never get enough test environments from the ops. And this is why the QA is suffering.
Ever happened to anybody in the room?
Oh, yeah.
Yeah, the rest are too shy.
Right.
So what do you do?
Without data, you just like, well, guys, try to do a better job in working with those environments, or you just throw money on it and provide more and more environments.
Which is typically not enough. So this is a real example from one of my teams. We started looking at a dev environment and test environment utilization. And as you can see, we had 10, which is the orange line available, and they were, if you look at this data, they were kind of pretty busy. That's why kind of understanding what the data means is important. So we started looking at this data differently. Like the data doesn't really look great, but what's underneath? Well, we started looking at how, by engineer, how many days on average do they use each of those test environments. And as you can see, everybody up to Baruch was doing quite all right.
Including Baruch?
No, 10 days seems too much, like 2 weeks. But everybody else...
It's calendar dates.
Yeah, we had people, as we found out, that would check out a test environment or some kind of environment, just not return it.
So that explains why we never had available environments.
Right? So what do? Well, number one, we immediately added some more environments. You see orange spike over there, but they immediately got consumed because the behavior of the folks has not changed. And then we wrote a little tool that would nag you for a few days after a certain expiry time, and then would just return the environment back to the pool. And so as you can see, our average utilization actually dropped in this particular case.
So this is an example of continuous improvement when we actually don't need the complete sample. Representative sample was enough. We had like 15 people that we actually monitor the behavior. Probably the engineering team is much larger, but most of them do the same, so that's okay to take a representative sample. We did it over time, and this is how we knew that we made a continuous improvement.
All right, let's try one more. Those tests are failing, CI is failing, it's Friday, I'm trying to go home. Those QA guys, they can never write a stable test suite. Ever heard one of those?
My code is fine, is the test suite that is failing.
Yep, so what do you do? Well, again, another example, we started actually gathering data. Every time a test suite would file unnecessarily, we asked the developer to go file a special type of defect in Jira, test suite stability.
And that's a custom type that you can easily add in Jira, and then every time, it's not my fault, it's the environment, just go ahead and file it under the environment.
And we started looking at the data, and if you look at this chart, the trend here is, the way you read it is, the red line is the incoming cumulative line of stuff that got filed. The green line is what we started fixing because we found out that there were actually stability issues in the suite. But the interesting part is, at some point, like in March, we've gotten to the point that
flats out.
Right, we kind of shook the system out of all the key issues. We left a couple that maybe were too difficult to fix. But here's an example again of using data to improve the collaboration between the teams.
And this is a return of investment. If we want to fix all the issues with the environment, we need to know about all the issues. This is where complete sample is important. We need to know about each and every occurrence. The third example is about trust, right? So we have what we used to call the ops team. They don't trust the developers. The developers want to break things, and here they come with their new
shiny garbage collector.
Shiny toy, shiny garbage collector. As long as garbage and shiny can come in one sentence, it's called Shenandoah, and they claim it's good, but we don't trust them.
And like it's holidays, nobody wants to deploy anything. Right?
So how can we build this trust between those teams in our DevOps organization? So we need to gather data. So our engineers that actually think it will be an improvement go to the lab and set up lab environments and test different types of garbage collectors. And as you see here, the bottom line, the purple one, is the system background, and just above it, just the tiny addition to it is the Shenandoah, the green one. And all the rest are all the chart.
Pretty strong improvement compared to the rest. Now, this is not a real sample. It wasn't taken in production. But if the teams believe that it's sufficiently representative, you can do something. And this is a real example. So the teams did.
Yeah, and then something very nice happened. That's a real-world example from the biggest, I think, social network in Russia, serving billions of transactions every minute. They did implement this change, and you can see the latency, the GC time right here.
One to nowhere, right? And the only way it happened is because the operations team responsible for the stability of the environment trusted that the data that was presented to them to implement such change was representative and sufficient.
Yep. And we would like to summarize it with a couple of tips and tricks about how do you go about that.
Data can be a very powerful weapon. Can be used for good, can be used for bad. So we want to make sure we use it for good.
So what's the most ridiculous and wrong thing to measure in software engineering? Anyone?
The worst metric for software engineer productivity. Anybody?
It's not that original.
Lines of code over there. Yes, I heard it.
There you go. Thank you very much. Obviously, lines of code. Lines of code is a horrible metric because it completely misses the point of what's important in code.
Right. The other problem with data, it's very easy to over-gather data and get hooked on data to the point where you're thinking about nothing but gathering and analyzing data. So data overload is good. And if you remember our example with test suite stability, at some point when we reached the saturation, we didn't have anything to measure anymore, to fix, we basically stopped measuring. We stopped caring because it takes time. The measurement and reporting and analysis, they take effort, right? And it's not free.
Another very important point, and it's kind of obvious and self-explanatory, but since we are talking about do's and don'ts, make sure that your data is reliable. Your samples are representative. You are measuring the reliable thing. So make sure that you trust the numbers, because actually going with wrong numbers and making decisions based on wrong numbers is actually worse than...
Can be worse than using any data.
Than using anecdotal data.
Now, one of the common mistakes we see when people, different teams with different perspectives, try to work around common set of data is differences in vocabulary. So, for example, this is a medium steak in Brazil, and this is a medium steak in Russia. They're not quite the same. So if you are in Russia and ordering medium steak, you should expect some different type of result than if you were in Brazil. So common vocabulary around the data you use to make your decisions becomes extremely important.
And also, metrics generate incentives, and incentives alter behavior. That's one of my favorite Dilberts. I'll give you a second to read through it. Yeah. Right. Going back to the lines of code, if we measure lines of code, if we incentivize around the lines of code,
bugs filed,
people will write a lot of lines of code.
Like with any system, continuous improvement is required. So you have to tweak your data collection, your data analysis as you go. Those things don't need to be tweaked every day or every month, but probably once a quarter it's worth looking at the data you gather about your own teams and how you collaborate based on that data and revisit what you want to measure and how you want to collect the data.
And going back to our example of tested stability, once we stabilize the suite, we don't need to measure it anymore because everything's fine. We will occasionally look at it. We already have this data. It will be stupid not to take a look, but it's not something that we will start our day with. Another important point is, and that goes back to data overload, even if you don't measure too much, if you only measure the right thing, you will end up with a lot of data. So there is like a raw data, like list of issues you have in Jira. There is something better, and it will be like product-specific dashboards. We go to same Jira and we see a dashboard of how we are standing. We don't need to go through all the issues separately. And the easiest way to go about is integrated dashboards. There are a number of solutions. For example, Grafana is one of them, and obviously JFrog emission control. I will show you a little example later. But try to elevate, try to look at the big picture before you dive into details.
Right. That's the only way we're going to get out of those engineering representing themselves with anecdotes from the daily stand-up, and the rest of the company actually operating on real actionable data, holding each other accountable, and improving the overall result. Now, Baruch, I thought we were at a DevOps conference.
That's a DevOps conference.
And I thought that DevOps is all about tools. So far, we talked about some Excel, some human time data.
Yeah, and you actually go and collect it manually and then look at it once in a while.
I thought automation was the thing in DevOps.
Yeah, that's weird. Let's
take it up to 11.
Let's
show some actual tools and examples of how you can use data.
Here's one of them.
It's not there.
It's not there. How about doing that? No, we don't need to. We're just doing that.
Well, it's going to be difficult for me to type. So
come on.
Well, then you drive, I'll talk.
Okay.
So here's an example of a dashboard that collects a bunch of data. This happens to be a SignalFx dashboard. At the top left, you'll see 3 containers running, right? They are processing requests, 1, 2, 3. On the right, you see the typical latency, right? And there are a variety of other items here that are representative of this environment. Now, this is an example of an elevated dashboard that gathers all the raw data, it processes them, and organizes in a way that is consumable. Now, one of the more common paradigms in DevOps lately is continuous delivery, right? And one of the ways of doing continuous delivery is a canary release. Does anybody not know what a canary release is?
Who heard about canary release? Let's ask.
Apparently, we need to explain.
Okay.
So a canary release is much like the miners in the old days. You would take, to make sure that there's no poisonous gas in the mine, they would take a canary, a bird in a cage, and will take the bird to the mine, and if the bird dies, the bird was more sensitive than humans to a particular gas, it's time to get out.
or not to get in.
That's right. So it's a very common pattern in continuous delivery where you deploy a portion of your environment, you observe it, you gather data on it, and you decide what to do.
So basically what you're telling me is that you don't want to use your entire user base as QA, but only a small portion of it.
That's right. That's right. You will only experiment on portion of our users.
And they are completely random. It's not that we have something against those people.
No, it just seems more humane.
It's just bad luck.
It just seems more humane that way.
Yeah.
So let's do that. Can you push a canary?
Okay, let's push a canary. We have here a very sophisticated command that is called
deploy canary.
Well, okay.
So let's go back to the dashboard. So right now there's a CI/CD pipeline doing a build, packaging the build into a Docker container, and at some point you'll see that the container, one of those containers will die, then another new container will spin up.
Here we go.
Oh, yeah, check this out. Yeah, the data is streaming on the right. This little green thing, that's a new container.
So third of the people now, the ones that randomly go into this particular container, have a shiny new version and test it out.
Except that we have a problem. If you look on the request latency per customer, on the right, it's just spiked. The CPU just spiked. The request per container just went red, and the productivity is going green. Like it's dropping right there. Well, since we're talking about machine data, the machine just detected that the canary didn't do well and automatically initiated a rollback. And as you can see, this container died, and this container spun up again, and we're back to normal.
And that's the previous version.
That is the previous version. Now, if you're able to do that data-driven in machine time, let's see how much time this takes. Let's color this. So this took us from 9:34:47 till about 9:35:26, less than a minute.
Yep.
To experiment and based on data to make a machine time decision of what should be happening. That's a good example of being data-driven and improving your continuous delivery based on the data.
And another example is going back to those dashboards and elevating and your human capacity of grasping enough data to make smarter decisions. And that will be an example of JFrog tool this time, JFrog Mission Control. And what you can see here is this dashboard that we took from different tools and merged together into one tool.
Okay,
so you can see here.
So explain, what are we looking at?
Yeah, so we see here this particular graph is commits. You see that we commit more and more.
Yeah.
Which is great.
Okay, so velocity is increasing.
Yeah. So this comes from source control. This is our average build duration. That's from our CI server.
It seems to be going up, but it's like not too bad. A minute 18.
Well, we build more stuff. It takes more time. In some point of time, we will have to fight this technical debt and decrease the build number. But for now, it's okay. We add new dependencies. You see this graph; it's going up.
Oh, that's why the build time is going up.
Of course, and because we committed new code. Base build storage. This allows you to predict how much storage you will need when you see this graph.
Oh, so like in the middle of the night, you don't run out of disk when you try to deploy a hotfix?
Probably not going to happen.
Could be useful. Wait. What? Like things are trending up and to the right over there. There's more commits. What is this average build promotion 0?
It looks like we don't promote anything to production.
Wait. So much for continuous improvement and delivery.
Well, we build a lot of code.
Well, that's important.
Yeah.
I hope this is not JFrog's own stats.
No.
Okay, good. So what's up with that? Why is it 0?
Here is your answer.
Oh.
You see this 257 vulnerabilities and graph that vulnerabilities that went down but at some point spiked. Here is where this new shiny NPM vulnerability discovered last week. Here it is. We used a lot of dependencies that used it.
So this data is used in your CI pipeline to stop the build?
This is why we didn't promote anything, because you really don't want to promote a build with this amount of vulnerabilities.
Yes. I wish more people were like you. Yeah, so this is a good example of gathering metrics from completely different systems, right? Source control, CI, Artifactory, and bringing it to something that can be reviewed in human time, gathered by machines, effectively presented, and some decisions can be made on that.
Right, so we merged together tools from different silos to give you a DevOps picture, I would call it.
So if you want to start a data-driven life, we encourage you to start with human time metrics, right? Excel is a perfect tool, but ideally, as you continue to progress in your evolution, you want to start going to machine time and machine time decisions and machine-gathered metrics that are fully automated.
And as you saw, Amy and Sheldon, it's about that. It's removing the blame game. We don't need to tell you, no, you don't do a good job. The numbers say it. This is very convenient.
Right? It obviously creates accountability, but most importantly, it creates that trust. DevOps is all about increasing velocity and therefore hopefully leading to profit. More often than not, velocity requires trust between different disciplines. The only way to build that trust is with data.
Common base for discussion. We are not fighting between us who's to blame. Instead, we are talking with numbers and we have this discussion. We are now participate in all these, no, you don't give us enough money, no, you don't provide us with enough leads. Now suddenly we can participate in this discussion and blame everybody else with numbers.
All right? And of course, as we talked throughout the entire talk, we believe that data and data-driven decision and data-driven collaboration across the key disciplines does create DevOps.
This is it. This is the collaboration which is the cornerstone of DevOps. This is what changed culture, because we cannot live in our silos anymore. We need to go out and speak with people and collaborate and communicate. This is DevOps. And so now we do have magically a couple of minutes for Q&A. Just to remind you, at JBaruch,
at Igolnik.
This is DevOpsCon 18. When you praise us on Twitter, please do use this hashtag. Obviously, DataDriven DevOps, the hashtag that we are trying to hype here around. And show notes, the slides are there, everything is there, video by tomorrow. And we do have a couple of minutes for questions. So thank you very much.